Welcome dear students to a very important topic related to the alkanes, and that is the halogenation of alkanes. The halogenation of alkane is an example of substitution reaction. Substitution reactions are those reactions in which an atom attached to the carbon of the substrate molecule is replaced by some other atom or the group of atoms. Now, what kind of substitution it is? It is electrophilic substitution because it involves the free radicals, and free radicals are electron deficient species. They are electrophiles. So that's why that will be called as the free radical substitution reaction. And as the free radicals are electrophiles, so this reaction can also be called as the electrophilic substitution reactions. My dear students, if we see the reactivity order of halogens, you know that fluorine is the most reactive one. That's why the fluorination of alkane that will be too fast to control. If you will just mix fluorine with an alkane, the reaction will be very fast because of the very high reactivity of the fluorine. But if you want to control this reaction, then you can mix the fluorine with some inert gas like nitrogen. So mixing fluorine with some inert gas like nitrogen and then making it react with the alkane, that will make the reaction slower, and that reaction will be under control now. The chlorination and bromination, they are moderate rate reactions, and usually when we are talking about the halogenation of the alkanes, we conduct the chlorination or bromination of the alkanes. Iodination, because iodine is very less reactive, so that is very slow due to very less reactivity of iodine, and it is also reversible. Why it is reversible? Because when some alkane reacts with iodine, it is reversible because you will get alkyl iodides and hydrogen iodide. Now, my dear students, hydrogen iodide is considered as one of the strongest reducing agents in the chemistry. So, it will reduce the alkyl iodide and it will convert it back into the alkane. If you want to make this reaction more in the forward direction, you will have to destroy this reducing agent Hi. And in order to destroy the reducing agent Hi, you will have to use some oxidizing agents like periodic acid, like HNO3. When you will be using some oxidizing agents like HNO3 or HiO3, then this iodide Hi that will be reduced and it will be converted to iodine and water. So this reaction normally is reversible, but if you want to make it more in the forward direction, destroy this Hi by using some oxidizing agent, strong oxidizing agent in the reaction mixer. HiO3 and HNO3, they will destroy Hi. And when this Hi will be destroyed, it will not be able to reduce the alkyl iodide back into the alkane, and then this reaction is favorable in the forward direction. Now, my dear students, the chlorination and bromination that takes place in the presence of light, and those reactions that take place in the presence of light, they are called as photochemical reactions. So chlorination and bromination of alkane is an example of photochemical reaction, and all photochemical reactions, they have zero order, so it is basically a zero order reaction. Now let us see how the chlorine reacts with the methane. Methane reacts with chlorine in the presence of sunlight. You will get one hydrogen will be replaced, CH4, methane. When one hydrogen will be replaced, you will get methyl chloride and HCl. This reaction will not stop, it will keep on going until all the hydrogens of the alkane, they are replaced by the halogen, if the halogen is present in large amount or excess quantity. Now, methyl chloride will be chlorinated in the presence of sunlight. It will be changed to methylene dichloride and HCl. Now this methylene dichloride is further chlorinated and you will get chloroform and HCl. The chloroform has last hydrogen, it will be replaced by chlorine and you will get carbon tetrachloride and HCl. So you will get a mixture of all these four products. No, which one of these four products will be present in higher quantity and which of the following will be present in the lower quantity means the relative quantities of all these products, they will be decided by the initial amount of the alkane and chlorine that you have used in the reaction mixture. So the ratio of the methane and chlorine which were initially used in the reaction mixture, they will decide the ratio of all these products in the reaction mixture. Which of the following products will dominate and other will be present in lesser quantity will be decided by the initial ratio of the methane and chlorine used. Now my dear students, what is the mechanism of this chlorination? As I have already mentioned that it is a type of free radical mechanism. And all the free radical mechanisms, they involve three steps. The first step is the initiation step in which the molecules are changed into the free radicals. And in the chlorination of methane, the chlorine molecules that will be exposed to sunlight, and due to homolytic fission, I have already delivered a lecture on heterolytic and homolytic fission. The link will be given in the description of this video lecture. You can watch that. As a result of the homolytic fission, the two chlorine free radicals will be produced. Free radicals have one unshared electron. Again, I have given a lecture on the free radicals. The link will be given in the description. You can watch that. If you have no concept of free radicals, if you have good concept of free radicals, then let's proceed on. So chlorine free radicals are produced. My dear students, if there will be no light, there will be no homolytic fission and no chlorine free radicals will be produced, the reaction will not be initiated. So light is must for the chlorination of any alkane. And my dear students, greater the intensity of the light, mean more photons the light will be having, more chlorine molecules will be changed to chlorine free radicals. So if you will increase the brightness of the light or intensity of the light, then the speed of the reaction will also increase. So the speed of reaction does not depend upon the concentration of the reacting species, rather it depends upon the intensity of the light. That is why it is a zero order reaction, independent of the concentration of the reactants. Now the second step, the slowest one, the time taking one, that is propagation. My dear students, suppose this is methane. Now chlorine free radical which has unshared electron, it will be highly reactive. So the hydrogen will take its electron and it will share with this chlorine free radical. As a result, you will get HCl. And now this carbon will be having one unshared electron. So you will get methyl free radical. Again, this methyl free radical will react with the chlorine molecule. It will be sharing its electron with one of the chlorine atoms. You will get methyl chloride and chlorine free radical. Again, a chlorine free radical is produced, so it will take on the reaction and This one is methyl chloride. It will react with this chlorine free radical. As a result, now again one electron of the hydrogen and one electron of the chlorine that will be shared. You will get HCl and then you will get CH2Cl. This one will be the free radical produced. This reaction will keep on going until and unless all the hydrogen they are replaced by the halogen atoms. So again CH2Cl, it will react with the chlorine molecule and again it will give its one electron. The chlorine will also take one electron from its bond. You will get CH2Cl2 dichloromethane and again of chlorine free radical. This chlorine free radical will again react with dichloromethane, and when it will react with the dichloromethane, the hydrogen will give its electron to carbon and it will share its electron with chlorine. Again HCl will be produced and you will get CHCl2 free radical. This CHCl2 free radical will react with again a chlorine molecule. As I have said, this will keep on going until and unless all the hydrogens are replaced. You will get CHCl3 and again a chlorine free radical. Finally, I will write it down in this form so you can understand it easily. These are two shared electrons with hydrogen. Again, this chlorine free radical, it will share its electron with hydrogen and you will get HCl and CCl3 free radical. Now, my dear students, in the last step, CCl3 free radical will react with chlorine molecule and again CCl4 and you will get chlorine free radical. In this way, through these 8 steps, there are total 8 steps 1, 2, 3, 4, 5, 6, 7 and 8. The 4 hydrogens of the methane will be replaced by the chlorine atoms and in this way you will get different products. The last step is obviously termination. It is the step of the stability in which you will withdraw the light flow from the reaction mixer and all the free radicals that will be present in the reaction mixers, they will be changed to molecules. I am just writing down different possibilities of the reactions. If two methyl groups they react with one another, you will get ethane as well. So basically, initiation is the step in which molecules are changed to free radical. So you will say that in initiation, the number of free radicals increase in the reaction mixer. During propagation, now the second step, you can see that the one free radical is being used, one is produced. In every step, one free radical is used, the one is produced. Again here one free radical is used, one is produced. So the number of free radicals, one is used and one is produced in every step, that will remain constant. in the propagation. And last is the termination. It is the step in which the free radicals are changed to the molecules. So during termination, the number of free radicals, they are reduced. And there is one thing very important. The students keep in mind the products of the chlorination of methane, as they will say that methyl chloride, methylene dichloride, chloroform, and carbon tetrachloride are the products which are the products of the chlorination of methane and HCl. They forget one of the products that can be asked in the MCQs, and that is ethane. So ethane is also a product of the chlorination of the methane. Keep in mind this one, because sometimes the question is asked that which of the following is produced as a result of the chlorination of methane. The options are CH3Cl, CH2Cl, and CH3CH3. So students, they get confused because they only memorize these products along with this one, but they forget that methane is also one of the products of the chlorination of the methane. So it was all about the halogenation of the alkanes. I hope so that this lecture will be useful for you people. If you find any difficulty, feel free to contact through the comment section. I will answer that. Till then, take care.